I already asked the student to help me as far as the reading goes today. Remember, today's October the 2nd. This is your assignment for today. We're working on page 68 of your packet. So if you have your packet, open up to page 68, section 16.1. It should be labeled solutions. Alrighty. Welcome, people who join us online. Today we're going to be talking about section 16.1. In your packet, it is page 68. Today, 8th period will be helping us out as far as the recording goes. I know usually I do 5th period, but I kind of forgot. So 8th period has agreed to help me out today. They're my pre-AP class, and they're a really, really good bunch. All right, so Victor was the volunteer for today's introduction. Go ahead, Victor.
It can be really exciting to explore a big underground cave like the one in this picture. Do you know how caves form? Believe it or not, water is the answer. Water slowly dissolves rocks, especially certain types of rocks such as limestone. When rocks or other substances dissolve in water, they form a solution.
Perfect. Thank you, Victor. All right. So we're opening today's discussion, and we're talking about how caves are formed. Okay. There is underground rivers and water that runs below the surface. And well, you have the formation of these caves because, as we know, we use our knowledge of rivers, and we know that rivers over a long period of time can start to break down certain rocks, certain minerals, okay? And obviously this is going to be a very long process, so you can imagine how long it takes to form these giant caves that some people go exploring in, okay? Me personally, you couldn't pay me to go into a cave. I've seen way too many movies where people go exploring in caves and something happens and they get stuck and somebody starts dying, right? So that's just not my forte. But if you ever want to go see a cavern, they have some really nice caverns over there by New Braunfels on the north side of San Antonio on your way to Austin. I hear it's really, really nice, really, really pretty. So that's just a suggestion if you're looking into that or if you happen to be in the area. Okay. Here in the valley, we probably don't have, any caves because we're pretty much flat. The only area you might find a cave in is probably over there by Rio Grande and Roma because it's a little bit hilly. It's a lot more rocky. Okay. But let's go back and let's talk about water. Water is one of those special substances that has the ability to break things down over time. Now, as you can see in this picture, there are certain substances that will degrade in water a lot quicker than others, okay? So, whatever material these little structures are made of, these little stones, obviously they're really, really strong because the water was not able to break down whatever material it is made up of, okay? And you could tell that it's a pretty big cave, most of them have pretty much high ceilings. They can be really wide or they can be very, very small. It just depends, right? So water, as it's passing over and over and over through time, it will start to break down those substances and create a solution of water, minerals, rock, and sediment, dirt, right? And they tell you here that one of those minerals that will especially degrade, one of them is limestone. All right. So Today's topic is what is a solution? Okay. So a solution is a mixture of two or more substances, but not just any mixture. It is a homogeneous mixture. Now you have to remember what a homogeneous mixture is. It is a solution where you have dissolved particles, and those dissolved particles throughout the solution, throughout the mixture, are spread out evenly. Okay? Particles of the solution are also too small to be seen and will not settle out of the mixture. So it doesn't matter if you have a homogeneous mixture, for example, Kool-Aid. Once you've mixed the components that make that Kool-Aid, the powder, maybe you put some extra sugar, and the water, once it has been completely mixed, those particles of that Kool-Aid, first off, they're too small to be seen. Second off, will never settle out. And what do we mean by settle out? They will never fall to the bottom and form a different phase or a different layer. Okay? That is just one special ability of homogeneous mixtures. Okay? Those particles, once they've been spread out, they will stay spread out. Now, here you're going to have a review, a quick 1-2 minute review of some vocabulary words that we've already discussed. So let's just go through it really, really quick. So first up is a compound. So compounds, the definition, it is a substance that always contains two or more elements in fixed proportion. And the example they give us here is iron 4 sulfide. Okay, iron 4 sulfide, it doesn't matter where I get my sample from. I know that sample will always have one iron and two sulfurs. Okay, it doesn't matter if I get it from the top, if I get my sample from the bottom, left, or right. The proportion, meaning how many I have of each element, will always be one iron and two sulfurs. Okay, so that's just a real quick review. And if I change the formula, then it's a different substance altogether. Next, we have a mixture, okay? And we've been talking mixtures all week long, so I'm going to go through this one really quick. Mixture is a combination of various compounds in varying proportions. There are two types of mixtures. You have a heterogeneous mixture that will have multiple phases, multiple parts that are unevenly distributed. And then you'll have a homogeneous mixture where there is one solid phase because the particles, whatever is in there, the parts have been evenly spread out. After that, we have a heterogeneous mixture, and you have some really good examples here. Heterogeneous mixtures, we said, will have different parts, different phases, okay? And those phases can probably or usually be unequally mixed, all right? In the example of the trail mix with the Chex Mix, well, you can tell that there's a bunch of raisins bunched up on that top corner while they're spread out on the bottom, right? They are unevenly distributed throughout the mixture. Same thing with those circles and squares. On the right side, you have a bunch of circles and a bunch of squares. On the left, very few of each, okay? That's unevenly distributed throughout. Next up is a homogeneous mixture. Homogeneous mixtures, the compounds that make up this mixture are evenly distributed throughout, and it's very difficult to tell them apart. So when you're creating, when Itza or Alexandra or anybody in class is baking a cake, baking brownies, well, obviously you're gonna start with the brownie mix. You're gonna have some eggs. You're gonna have some oil and maybe even some chocolate chips. I don't know. People put different things in their brownies. But eventually at the end, you're going to mix them real well because you want to make sure that every single piece of that brownie tastes exactly the same. Okay? You don't want one side to taste really, really good and then the other side's not mixed very well because it's going to taste bad, right? And you're not going to want to share your brownies. And who wants that? In the picture on the right, you can tell that all these circles and the squares have been evenly distributed. If you were to cut this into 4 pieces, each piece would have 2 squares and 2 circles. The next one is a solution. And the example they give us here is Kool-Aid. When a substance dissolves into another substance, okay? The example here is Kool-Aid. So before you had this solution, you had a packet with some powder and a pitcher of water, right? And you took that packet of water, you put it inside, you dropped it in the water, and then you mixed it real good so that that color spreads out and that flavor spreads out evenly. Okay? Again, solutions are types of homogeneous mixtures. So now we're going to go to a type of heterogeneous mixture, a suspension. When it comes to suspension, you can usually see the different phases of the heterogeneous mixture. They'll usually separate into layers over time. The example here is probably oil with water. And then you could see that they're putting like some red food coloring, and that red food coloring is floating right in between both solutions, both phases. And if she puts enough, or he, it'll probably create a third phase in between these 2 solutions. Usually, suspensions are arranged by density. Those with the heaviest or biggest density will be at the bottom. Those with the lowest will be on the top, or the lightest. Next, we have a colloid. Okay, colloids will have large particles that you might be able to see. And they're usually, suspended in between smaller particles. They do not settle out. Once those large particles are there, they don't usually move, and they won't form different layers. And I'm not really sure about this example. I don't know if they're talking about clouds. I don't know if they're talking about smoke or fog. It's really fuzzy as far as this example goes. But I can think of one quick example of a colloid. We talked about Jello the other day. Gelatin is definitely a colloid. And I think that's it. Yes. All right. So that's just a quick review comparing compounds to mixtures and then types of mixtures. Now, solutions will be broken into parts. All solutions will have 2 parts, the solute and the solvent. The solute is a substance that is being dissolved, and the solvent is the substance that does the dissolving. Okay, and how does this work? Well, let's see how they say it. Particles of a solvent pull apart particles of the solute, and the solute particles spread out throughout the solvent. Okay, so if you're dropping a giant ball, or a giant sample of salt into some water, those water molecules, that H2O molecule, will start to basically eat at that giant sample of salt to break it apart. So it's going to go to the atoms on the outside and take it piece by piece. Those molecules will surround one atom of salt and pull it away. Other particles will go to the next atom and pull it away, and the next atom, and the next atom. And it's going to keep on eating at that solute until it's completely broken up, and all of those particles are floating around, surrounded by water molecules. Okay? Water has unique properties, very unique properties. Salt water, such as the ocean in the figure below, is an example of a solution. In a saltwater solution, salt is the solute, water is the solvent. Okay. We've been talking about ocean water like all week long. And we've already answered this question, but we're going to talk about it again. If you are a scientist working with a water sample from the Atlantic Ocean and determine that 3.5% of it is dissolved salt, predict the percent of the dissolved salt in a sample of water from now the Pacific Ocean. So you right now have studied the Atlantic. You're making a prediction about the Pacific. Will the amount of salt in your sample be the same or will it be different? 8th period, what did we say? Will that percentage of salt change because I took it from the Pacific instead of the Atlantic? No, it's not going to change, right? That the world's oceans are all connected. It is one homogeneous mixture. So if I have 3.5 in the Atlantic, I'm going to have 3.5 in the Pacific. I'm also going to have 3.5 in the Gulf and any other ocean around the world. Okay? And that's just because it's a homogeneous mixture. The salt that's in this ocean water is the same all over the world. Now let's talk about soluble versus insoluble. Not only salt, but other solutes can dissolve in water. In fact, so many solutes dissolve in water that water has a special name. It's known as the universal solvent. And I know that you've probably heard this before, but this is a really, really important term. Make sure that you always remember that, because just about every solution has water as the solvent. Okay? Even rocks can dissolve in water, which explains the cave part of our introduction that Victor read. A solute that can dissolve in a given solvent, such as water, is said to be soluble in that solvent. Okay? So tell me, guys, what do you dissolve in water around your house? Sugar. Thank you. What else? Where else do you dissolve substances in water?
Chlorine.
Chlorine is another solute. What's another solute other than sugar and chlorine? Come on, I'm talking to the other people who haven't answered. There's a lot of examples around your house that you can think of that you dissolve in water to use. What can you think of, guys?
Kool-Aid, tea.
Tea, Kool-Aid. Okay. What else?
Chocolate.
Chocolate, definitely. Let's go to cleaning. As far as cleaning around the house, what dissolves in water to help you clean?
Fabuloso.
Fabuloso. Thank you, Alexandra. Yes. Clorox. What else? Soap, right? And you can talk in terms of dish soap or laundry detergent, right? Now, some laundry detergents, back 10, 20 years ago, contained insoluble compounds that created problems for our water system. Okay, I don't know if you've ever heard of a commercial where it says this laundry detergent is sulfate, and paraben free. Why is it sulfate free? Well, sulfate is one of those substances that doesn't dissolve in water, and it can create problems for our water system. You have too many sulfates, they're going to build up and they're going to create problems when it goes to get cleaned at the water plant. The more sulfates, the more work we have to do at the water plant, the more taxes that we have to pay. Well, not necessarily you yet, but me, Coach, your mom, and your dad, right? Because we're the ones who pay the taxes for our house. So what these companies did to help out is that they started making laundry detergent that's sulfate free. Okay. Another example, although most solutes can dissolve in water, some solutes are insoluble. Another example is oil. Oil is one of those substances that it doesn't matter how strong or how long you shake or you try and mix it. If you look at Adrian, I'm sure Adrian is a really strong guy. He's in football. I can have Adrian try and mix oil and water with all his strength for as long as he can do it. And Adrian's a strong guy. He's a football player. I'm assuming. I've never met Adrian, but I'm assuming he's a strong guy because not anybody plays football. But it doesn't matter how long Adrian shakes or tries to mix oil and water. Oil is insoluble. It will begin to separate as soon as Adrian puts that cup down or that bottle down. You will see the oil rise to the top. You will see the water go to the bottom because of that difference in density and the fact that oil is just insoluble in water. Okay. And here you have an example of an oil spill in the ocean. Not only are oil spills costly to clean up, but oil also damages, marine life, plant and marine life and plant life. Okay, so these big companies, yes, it's fine that they're drilling out there in the ocean, but they have to be extra careful because oil is definitely insoluble in water and it can hurt some of the animals and plant life in the ocean. So I don't know about you, but I'm not for drilling in the ocean. All right, solutions and the state of matter. So the question in this paragraph is, can solutions be in the three states of matter? And we know the three states of matter, right? Solid, liquid, and gas. So we've already talked about a lot of liquid examples. Now we want to know, can solutions be in the solid form and in the gas form? The answer is yes. Okay. If you're looking for an example of a mixture or a solution in the solid state, you can think of alloys. Alloys are usually a type of metal mixed with something else. Okay. An example is bronze. Okay. I don't know if you guys own anything that's bronze, but bronze is a mixture of copper and tin. All right. And it's an example because most of the time at room temperature, copper and tin mixed together will be a solid, will be in the solid state. Now, if you're looking for an example in the gas state, you're sitting in it right now. Remember when we talked about air? Air is a mixture. Remember that simulation that we saw that when Gael said, oxygen's only 20%, miss? I was like, yeah, I couldn't believe it either. So the air in the room that you're sitting in right now is 78% nitrogen, 21% oxygen, and less than 1% carbon dioxide, methane, argon, and other gases. Okay? So you have an example of we talked about a lot of examples of liquid. We said alloys are examples of mixtures in the solid state, and air is an example of a mixture or a solution in the gas state. Okay? So solutions can be in any three states of matter. Okay? Wow, that was quick. So we're at the end of our lecture for today. A solution is a homogeneous mixture of two or more substances in which the dissolved particles are too small to be seen or settle out of the mixture, right? They're never going to create two phases. Once those particles dissolve evenly, they stay distributed evenly. You cannot see them and they will not settle out. In a solution, you'll have a solute and you'll have a solvent. Okay? The solute does the dissolving. The solvent is the one that dissolves. Okay? A solute can be classified as soluble or insoluble, depending on the substance. Solutions can be in any of the three states. If you're talking in terms of liquid, we talked a lot of examples in liquid form: salt water, Kool-Aid, tea, soap and water. All of those are in the liquid state. If you're looking for an example as a solid mixture or solid solution, alloys are solids at room temperature. And if you're looking for an example of gases, of a solution is gas. The gases in the air right now around you. Okay. Now you have 9 questions to do. You have plenty of time to do it. Now, if you finish early,